Mrs. Aren't here. This is your Math 3 Week 4 Lesson 2, and it is all about finding the period of a trig graph. So let's talk about what the period of a trig graph is. The period is the distance along the x-axis that is required for a function to complete one full cycle. So if we look at our sine of x graph, where x is the angle of rotation, here we're looking at our x-axis in radians. So we've got 1 pi, 2 pi, 3 pi, 4 pi, and the sine graph starts right on that midline, goes up to 1, down to -1, and back to where it started at 2 pi. So the period for the regular sine function is 2 pi. That is one full cycle. It's one full rotation around the Ferris wheel. If you remember going up the Ferris wheel, down to the bottom, and back to that midline where we started. So 2 pi is the period for the sine function. The same is true for the cosine function. It starts at the peak at a height of 1, then goes down to -1 and goes back to the peak. So in that space, 0 to 2 pi, it completes one full cycle of the graph. Now, of course, these graphs continue going on for infinity, to positive infinity, negative infinity, but every 2 pi units, it completes one full cycle on these graphs. So what if the frequency is different? Let's take a look at example 1. Our job is to find the period of these different graphs that we're looking at. And so it might help to locate the midline. It might help to just try to locate a starting point. It doesn't matter if you consider it as a sine function or if you consider it as a cosine function. That's up to you how you want to view it. So here on example A, maybe it's really easy to locate the peak point, which is at pi over 5. So if this were a cosine function that's just been shifted, and it starts here, and it goes down to the bottom, back up to the next peak. Well, now we need to know, what is that distance along the x-axis that it took to go from peak to peak? Well, it started at pi over 5, and it ended at pi, one full pi. So we could do some subtraction, might involve some fractions, that kind of thing, or you might just start by counting the spaces. So each one of these hash marks represents 1 pi over 5. So from here to the end, we'll count the spaces. So there's 1 pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5 is the period or the distance it takes to complete one full cycle. It would be the exact same if you considered it as a sine function and looked at the midline and went from start to finish on the sine function. So here on this graph, the midline is at -1. And so if we look at the starting point here on our y-axis at 0, -1, and we find that ending point where it comes back to that midline after it has gone up and down and back to the midline, that's from 0 to 4 pi over 5. The period is 4 pi over 5, no matter how you look at it or view this graph. So let's take a look at another example down here in part B. We have another wave that's going on for infinity, and our job is to find the period of the function. How long along the x-axis does it take to complete one full cycle? So again, you can choose to look at it as a cosine function, looking at the peaks. But then, of course, we need to determine that distance. So every hash mark on this graph represents pi over 2. Pi over 2. So if we start here, then count the spaces. So there's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Now, of course, 4 pi over 2, that reduces. And this is actually 2 pi. 2 pi. If you want to consider the midline, well, we'd have to locate the midline. It's at +1. And then we would need to find a starting point, go up and down and back to the midline, and the ending point. And we can see that from -2 pi up to 0, that's a distance or a space of 2 pi. So no matter what, that period is 2 pi. Oh, that was all the examples. So head on over to Delta Math, practice finding the period of the different trig graphs, and good luck out there.